Hi folks, we're going to take a look at number 6 from the Unit 6 assignment part 2. So they give us an equation for the area of a circle, and they want us to find an expression for the radius and then find the radius and area when x is equal to 10. All right, so this is an odd way to be seeing the area of a circle because the more familiar representation for the area of a circle is a equals pi r squared. Okay, so our goal is to take this expression and make it look like pi r squared. And the first thing I notice is that there's a common factor of pi. Okay, so we'll start with that. So area is pi. If I remove the common factor, I'm left with x squared plus 10x plus 25. And hopefully this expression here is a perfect square. So I'll have something squared. That something will be the radius. And when I look at this here, it looks like a pretty good candidate for a perfect square because the first and last terms are perfect squared, x squared and 5 squared. And when I multiply 2 times x times 5, I get 10x. So that means this is indeed a perfect square, and it is just x plus 5 squared. Okay, if you want to be convinced, just go backwards, square the first, square the last, and twice the product of first and last. All right, so now we found this expression written in a different form, but it fits with the model for our traditional area of a circle, which is pi r squared. So that means, therefore, the radius is equal to x plus 5. Okay, so that solves part A. And if I want part B, well, they just asked us to find the radius and the area when x is equal to 10. So radius, pretty easy, just 10 plus 5, so 15 centimeters. And then the area, of course, is just going to be pi times 15 squared, pi times 15 squared. So that's 15 squared is 225 times pi centimeters squared. Okay, and I'm going to leave it in exact form. I could have also approximated. All right, so just to recap a question like this, step number 1 is to take the expression you're given and rewrite it so that it fits the formula you have, which in this case here was pi r squared for the area of a circle. And then from there, we were able to deduce what part of that expression represented the radius. And then once we had a particular value, we were able to calculate an exact radius and an exact area. Okay, that's it for this one.